Okay, good afternoon, class. Um, there's construction going on in the neighborhood just across our residence, and also um, our the connection to our um, lights at the second floor is not working, so men have to come in and break into the roof so they can access the wiring. So if you hear some pounding or hammering, it's because of that. Also, I'm just using data connection here in the province. So not sure if I'm choppy or laggy right now. Just thumbs up if my connection is fine, or thumbs down if not. And okay, all right. I only have a 4G plus data connection here. Um, anyway, I hope it's fast enough. Now, I just plan, as I have announced in Canvas, to just answer some exercises on Module 2, specifically about uh, differentiation formulas. So I prepared several examples here. Let me start right away. So let's start by um, illustrating the product. And if you um, reviewed or studied the topic of product and quotient rules, you may already be familiar with the formula or the rule which allows us to differentiate the product of two functions. Say f, function capital F, and function capital S of those two functions. Now, we denote the derivative by putting a prime, or they call this apostrophe, or we just read it as prime. So we read that as Fs quantity, open close quantity prime, meaning the derivative of the product. So this can be obtained by the following formula: Fs prime plus F prime. In words, it's the first times the derivative of the second plus the second times the derivative of the first function. So let's apply that. We won't prove the formula. It's beyond the scope of our course, by the way. So here in the function given, we have a product of two functions, namely x squared. Let's call that our f, and 2x minus 1 quantity to the 5. Let's call that our s. Okay, so this is f, this is s. So applying this formula, we have x squared, f prime of x equals x squared times the derivative of the second function here. And for this, we need the power rule, more particularly the chain rule for power functions or for powers. You may already know that the derivative of x to the n with respect to x is obtained by bringing down the exponent, subtracting 1 from the original exponent. Okay, but the base here is a function of x, so we have to apply the chain rule. And the chain rule states that the derivative of a function of x raised to n can be obtained by applying the same what they call this process of bringing down the power, then subtracting 1 from the power, but additionally multiplying by the factor, which is the derivative of the base. So you bring down the exponent, subtract 1 from the exponent, differentiate the base f. So let's apply that to obtain the derivative of 2x minus 1 to the 5. So if we differentiate, we bring down 5, subtract 1, so that's to the 4, and then differentiate the base. And what's the derivative of 2x minus 1? Let me see if I can switch from, I'm not connecting my laptop to the same data connection so as not to divide the bandwidth, which will shorten or they call this make the connection slower. So let me see if I can see your somebody chatted. Only good afternoon, sir. So what's the derivative of 2x minus 1? That should be 2. Okay. Now, if you have problem understanding why the derivative of 2x minus 1 is 2, then that means you have to review the basic rules of differentiation and properties also of differentiation, like constant times function rule, sum and difference rule, and here we are actually using the product rule, and then the next examples, quotient rule. Okay, so this 2 here is the derivative of 2x. Okay, if you get the derivative of the base to x minus 1, you distribute the differential operator, or you just differentiate term by term. The derivative of 2x is 2. The derivative of negative 1 is a 0, right? The derivative of a constant rule, constant function rule states that the derivative of any constant is 0. Anyway, let me just try to connect. Let's just tell me if my connection is getting laggy because of this. Okay, I'll be joining using also my laptop so I can see or read your messages in the chat box without having to switch here, switch screen here. Okay, there I see my own. So chat box, let me see. Nobody's messaging. Perfect. Yeah. So the derivative of a constant is 0, so that means we have a 2 here. So if we simplify a little bit, we have 10 times 2x minus 1 to the 4. For the derivative pa lang yan ng second function. Let me put that here. As originally differentiated without the simplified expression yet. Okay, next. Plus the second times the derivative of the first. Is the screen large enough for you to read? Okay naman yung screen. Okay. Kasi baka pag ni-record ko to, the recorded version might show, not sure. It's the same screen size, I hope. I did not use my laptop to originally start the meeting. I use the tablets. So usually Zoom will record based on the gadget you use to originally create the meeting. So kung cellphone to, lalong maliit yung screen. But anyway, so doon na tayo sa SF prime. Plus, second function, this one here, times the derivative of the first, which is x squared. The derivative of x squared is, anyone? What's the derivative of x squared? 2x. This Araneta, thank you. Now, in the quiz, the upcoming quiz on Tuesday and the seat work tomorrow, if a question like this will be asked, there's no need to simplify after this. Okay, there is no need to simplify after this. But it's okay if you do some little simplification after. Okay. So if I were to just do just a little more simplification, I would write 10x squared times 2x minus 1 to the 4th plus 2x times 2x minus 1 to the 5. Now, in our previous calculus courses in the 5 years or so, we usually ask or require students to factor out this expression. Okay. Now, just let me show what or how the expression will look like if simplified by factoring common terms. Like here, you can see that 2x minus 1 to the 4th is the greatest common factor. And if you factor that out, okay, out of the first term, then you'll have 10x squared. And then if you factor that out of the second term, you'll be left with just a power of 1 and the 2x here, then a power of 1 here left. And then you just simplify the expression in the braces to write the final answer as, okay, this is 4x squared, so 14x squared minus 2x. So that if you are asked for the second derivative, you can again apply the product rule. Actually, this should be the way we should write our final answer. Okay, but as it turns out, there will be no need to do such a simplification process. You can stop right at the first application of the formula. I mean this part here. You can stop here, right? I mean this one here. And if you wish, of course, there's no harm. And actually, it will just be very simple. You can write your answer by a little more simplification. Just a mere rearrangement and multiplication of terms. Okay? Rearrange, then multiply those that are easily calculated. Like the 5 times 2, okay, then the 2x. Okay, you write constants, coefficients first in a series of products, then perhaps the complicated ones last in the series of products. Anyway, if you have questions, just raise your hand or unmute your mic. Anyone? Continue. I hope you've already studied the videos. So if you did, you already know the derivative of e to the x. I wanted to really discuss the derivation of what they call this, the derivative of e to the x. What's the derivative of e to the x? Yes, it's itself. You can watch the asynchronous videos. Those were the videos I actually recorded 2 years ago for my very first calculus class after the lockdown. Kasi may konting class pa noon eh. Tapos, ewan ko kung alam niya yon, binigyan na lang ng pass lahat ng mga tinamaan noon nung nakahati yung semester dahil wala pang announcement ng lockdown. And then kalagitnaan ng semester. So, nangyari no, bigay na lang ng pass sa lahat. And then yung the next semester was be really full online fully. So videos doon. I believe baka ng e to the x, which is itself. It's the only function whose derivative is itself. Of course, multiples. Like if you differentiate, can you still hear me? Am I still connected? Messaging to the chat, yes, sir. The other gadget is disconnect. So let me totally disconnect. You can still see my screen, I hope. So if you differentiate this function here, it will be itself. Why? It's a constant times a function, and according to the rules of differentiation, you can get the derivative of a constant times a function by taking out the constant and differentiating the function. And again, the derivative of e to the x is equal to multiples of e to the x is a multiple of e. Or you can just visualize or take into mind which is the first function and the second function. So h prime of t, or sometimes we can write the differential operator d dt or d over dt. But of course, economy-wise, this one is preferable. Unless we're in the subject of differentials. That's when we will need that alternative notation. And we go to this subject, which I think will be excluded or might be optional na lang. Now the derivative h prime of t is e to the t, the derivative of the second. And how do you get the derivative of square root of t, or what's the derivative of square root of t? You can write it as t to the 1/2, although we have discussed in the video, the proof or the derivative of square root of x was shown to be 1 over 2 square root of x by the use of the limit definition. Still remember, ito na yung huling natin asynchronous class ko na nagtinuro ko. Yung limit of f of x plus h minus f x all over h as h approaches 0. Okay, but we can also get that quickly by applying the power rule. So to differentiate this, you bring down the power, that's 1/2, subtract 1 from the power, minus 1 is -1. And then bring down a negative exponent, so you get 1 over 2 square root of t. I won't be asking students to recite if I'm only using one guide, okay? But if you do have a question, you just unmute your microphone so I can know. So differentiating the second, we have 1 over 2 square root of t the second function times the derivative of the first itself. The derivative of this is itself. So I did differentiate the first term. Okay, sir, you didn't differentiate this because the derivative is itself, so doesn't appear to be. But don't forget, you do have to differentiate the other term. And if not required to simplify, you can leave your answer in this way. If this is a file upload question where you have to write on a paper and take a scan and upload, you leave it as this. If asked to simplify a little bit, then shouldn't be hard to rewrite the answer as this. Just that. There's a more compact or rather more elegant way of writing the final answer. Pero okay na to. Kung dalawang to, kahit ano dyan. So if not asked to simplify, you leave it as this, but you may still give this. But if asked to do a little simplification, at least you should give me this. And then no more need to get the LCD and the like. Okay? So let me just check how we are participating. Okay. Next. Yes, you can interchange e to the t and square root of t. So, next, quotient rule. Numerator, denominator, of course, form the parts of a quotient. So how do you differentiate a quotient? You use the formula d n prime minus n d prime over d squared. It's always denominator times derivative of the numerator. Okay, you cannot first get the derivative of the numerator times the derivative of the denominator. It'll always be in this order: d, n prime, n, d prime, and then minus. So let's apply that formula. So this is our n over d. So d, copy d, differentiate n. The derivative of ln x you should already know by now to be 1 over x. Forgive the noise, okay? So we have derivative of ln x as 1 over x minus numerator ln x, derivative of the denominator, which is 1. Derivative of 1x is 1. Derivative of 2 is 0. So 1 here. All over, don't forget the square of the denominator. And then this is it. Okay? This is it. This is the final answer. Now, if asked to simplify a little bit, maybe just drop some of the terms like 1 here, or if it were a 2, you put it here, right? Just rearrange, then there. Although, if we are to use algebra, really, you will have to write this as this. If you are to really simplify in the in simplest form. But again, without simplification, this can be given as your final answer. Any question? Unmute your mic if you have a question. Okay, are you listening? Next, chain rule for powers again. You differentiate a power of a function of x. Okay, let's just use the f of x there to the n. We bring down, subtract 1, differentiate the base or the function f. Okay, so we bring down 8, subtract 1, and you already get partial points for showing this part of the answer there. But you don't stop here, you have to differentiate the base. And what's the derivative of sine r? Anyone? What's the derivative of sine r? Sine x? Cosine x. Very good. So we differentiate the base. We're looking at the base, sine r plus cosine r, and we're differentiating it with respect to r. So derivative of sine r is cosine r, plus the derivative of cosine r, negative sine r. So beside this expression should be cosine r minus sine r. Take note again, the derivative of cosine x with respect to x is sine x, while the derivative of sine x with respect to x is negative cosine x. Take note, it should be positive, it should be negative. So they're just interchanged. The derivative of the sine is the cosine, the derivative of the cosine is the sine, but for the baliktad, negative sine x. The derivative of cosine x is negative sine x. Then the derivative of sine x is cosine. So it's the derivative of the cosine that is negative sine. So ito yung final answer. That's already simplified. As in simplified. Okay, any questions so far? Okay. Next, quotient rule again. So dn prime minus nd prime. Don't need to really write it over and over if you're already familiar with the formula. I've memorized the formula. So y prime, or sometimes we use dy dx to denote the derivative of y with respect to x. Prime is always used if we have x as the independent variable. If it's understood to be, if it's x, then y prime is understood to be with respect to x. Now, if it's not with respect to x, usually we indicate that by using the differential form, or yes, the differential form. Like if you're differentiating y with respect to t, you do not usually write prime if several variables are in. But anyway, for now, okay, we will use y prime or dy dx. But this one is theta, so what is this? Dy d theta. Okay, or if you still want to use the prime notation, you have to indicate the variable y prime with respect to theta. So we have 1 plus secant theta times derivative of the numerator. What's the derivative of tangent theta? Anyone? Derivative of tangent theta? Yes, sec squared or secant squared theta. And then your cotangent x, the co-function of tangent, negative cosecant squared x. Okay, take note of memorize the formulas, okay, for the derivatives of trig functions. So derivative of tan is sec squared. Then minus tangent theta times the derivative of the denominator. So derivative of 1 is 0. Okay. So we just write the derivative of secant theta. What's the derivative of secant theta? Anyone? Mr. Roque answered, and Oblenida. Anyone else? Romualdez, Belen, Roque, Grantosa, Cinco, Perez, de Belen, Nares. Okay, same names, Raneta. Okay, good. Mr. Roque again, secant x, tangent x. Okay, so differentiating secant, so we have secant theta tangent. Then just write over the square of the denominator. You have your answer. Each part credit, okay? So if this were a 10-point item, each might be assigned 2 points. The sign has to be correct, of course. Okay. Next, f of x equals quantity e to the x squared plus square root of sine x, quantity closed, raised to 12. So first, the power rule, quotient rule for powers. Copy the base. Then subtract 1. Differentiate the base. So differentiate term by term. Derivative of e to the x squared. Anyone? How do you get the derivative of e to the x squared? Not quite. Is 5 not quite? Yes. E to the x squared times 2x. For chain rule, for exponents or exponential functions rather. So suppose the power of e is not x, but a function of x. So it's still the same. The derivative of e to the x is e to the x, right? But what if the power is no longer just x, but a function of x? So it's still the same. You copy e to the f of x as with this one. But again, you differentiate f of x. That's the factor. Okay, the correcting factor. Say. Okay. So in addition to e to the x squared, because we are differentiating the first term, you differentiate x squared, and you know that would be 2x. Hope you're following. Plus the derivative of the second term. Anyone can help me finding the derivative of square root of sine x. How do we get that? Square root of sine x. Differentiate that with respect to x. Square root of sine x. What rule do you need to apply first? Or actually, there's just one rule you need to apply here. What rule do you need to be able to differentiate this function, square root of sine x? Square root is a radical, but you can write a radical as a power. Sine x quantity to the 1/2. Now you apply the power rule here. Remember, power rule, bring down the power, a constant power, subtract 1. Bring down, then subtract 1. 1/2 minus 1, negative 1 here. But you have to differentiate the base. The derivative of sine x is cosine x. So you have that here, the correcting factor, correction factor. Okay? So we will have here that term 1/2, or if you want to still use radicals, that would be 1/2 square root of sine x, cosine x. But it's okay to use exponential form or power form. So let's use the radical form. Too many to fit in that narrow screen. And you're done. So you can write this one as, if you want, as 2x e to the x squared, and this one here as cosine x over 2 squared cosine x. Okay, I want you to try this out for like 3 minutes, then I'll discuss. Okay, so differentiating f prime should be f of x, or f of x. So f prime of x equals, so quotient rule. So we have e to the x times the derivative of the numerator. Let's focus on that. Now, for this, you need a series of quotient rules. Oh, kailangan ba? Mamaya pa yun. Okay? So first, we need the quotient rule for logarithms. Okay, the derivative of ln x is, by the way, 1 over x. Now, if it's not x, but a function of x rather, like in this one here, you still get the reciprocal, but you multiply by the derivative again of f. Or sometimes you can just use f prime of x over f of x. Alternative. So if we apply that to get the derivative of this one, so we will have to get the reciprocal. Let me recap. So we get the reciprocal of the function of x inside ln. So we have a 1 over that. And then we differentiate. We usually write it beside, but let me write it above because it will be just numerator times numerator. So here, I will write the derivative of this expression. So the derivative of x squared is 2 to the x, and then the derivative of this one. What is tangent cube x? But tangent x quantity cube. Don't get confused, right? It's just a simpler way of writing a power of a derivative or a trigonometric function. So for this, you need to apply the power rule. So power rule, we bring down 3, subtract 1, and then differentiate the base. The derivative of tangent x, secant squared x. Okay, there, you're done. Or another way of writing this one would be 2x plus 3 tangent squared x. This one here. There. Now here we need a series of chain rules to get the derivative. You need the chain rule for powers, chain rule for logarithms, and then chain rule for exponentials. Okay. Minutes. It got disconnected. Okay, for this one, so you have to think of the radical as a power. So changing that to power form, that's to the 1/2. So power rule first, chain rule for powers, bring down. Then subtract 1. And then differentiate the base. Term by term. Derivative of z is 1. Then differentiate this. You will be needing chain rule for exponentials. Take the reciprocal. Okay, we're dealing with ln. Take the reciprocal, copy as a denominator, and then differentiate that one. Put it above here. Derivative of 1 is 0. Derivative of e to the sine z, you need the chain rule for exponentials. So copy e to the sine z, then differentiate sine z. So copy this one, differentiate sine z. So when I check a problem like this, there are a lot of things to look for. Okay, this deserves some points, like perhaps for this 6 out of 10, and each one has a point allotted to each term usually. All right. Composition of functions. Okay, sine. What else? E. Right. Let's just not make that complicated. There. So differentiate that. Ln of the sine of e to the quantity tangent squared of x cubed. So start with, since we have lack of time. So ln is the outermost function. So you have to take the reciprocal of whatever's inside ln. There. And then you differentiate this. And to differentiate this, you need to look into this. Okay, you're now in sine. So the derivative of sine
is cosine. So the derivative of sine of this is cosine of this. Okay, but don't forget you have to differentiate the one inside. Chain rule. Okay. So differentiating that one inside, which has a function of x, the derivative of e to the something is e to the something. So we have. But we have to differentiate the something there. The one inside the rectangle there, the box expression. So differentiating that one, you have tan squared, which is just tan quantity squared. You bring down 2, subtract 1, it's just a power of 1. But you have to differentiate the base. Okay? Sorry. Now here. Papasok ka ng papasok. Hanggat ma-exhaust lahat ng nasa composition. So 3x squared outside. There's a lot of terms there. Right? And a little simplification, if needed, if required, would require just rearrangement of terms. And there's really no standard for ordering your terms in the rearrangement. 6x squared, tangent x cubed, pwedeng kahit. Usually nasa last yung mga derivative, trigonometric functions. I'm just merely rearranging, okay? Para lang mas maganda tignan. Okay. But ito ang titignan ko dyan. Usually, titignan ko lang lahat kung nandun yun. Pag may nawala siguro sa deduction lang yan. So, hindi mo man nailagay ito, nakalimutan mo, naging careless, at least may 8 out of 10 ka siguro. Kasi last naman na yun eh, di ba? Okay, tomorrow, we have a seat work. You have a seat work before the discussion. So 10 minutes na yun. 10 minutes lang yata yon. So 2 points yon. So mag-start sa start ng class yon. So better log in sa Zoom 5 minutes before kasi ibibigay ko yung access code. And then naka-Zoom tayo, naka-open yung camera nyo. Okay, kapag seat work, ganun tayo setting na. So those who have questions, you can stay, and the rest you may go. I'll be uploading or posting the link to the recorded video or to the video recording of our synchronous session later. Okay, so you can review. Don't forget quiz. Next Tuesday. Quiz this coming Tuesday.
Thank you, sir.
Thank you, sir.
Thank you po.
Bernabe Valmonte, you have follow-up question? Meron? Bernabe or Valmonte?
Sir, may tanong po ako. Sir,
Mm.
regarding po yung syllabus, yung first long test, next week po yung nakalagay na schedule.
Tuesday.
Will it push through po next week? Yung first
Oo, kasi yung iba, ano na nakapag-derivatives na this week eh.
yes po,
Quiz
sir.
na. O tapos yung iba Monday. So ako, medyo usog ko pa ng Tuesday para konting time pa mag-review kayo. And then, makapag-review pa tayo sa sa Monday.
Okay po, sir. So, next week po ng
O
Tuesday,
lalo
yung first.
na, ano na kasi, 24-25, walang pasok dahil
Opo,
validation.
wala pong pasok.
Kaya kailangan talaga.
Sige po, sir. Thank you, sir.
Alright.
Ano po, sir? Thank you po.